So in this video, we will be going over the basics of acids and bases. This is not going to be comprehensive. This will not be going over all of acid-base unit. This is kind of just the basics of what you need to know for Unit 1. So basically, TLDR, acids are proton donors and bases are proton acceptors. And the proton in this situation is hydrogen. So this might seem really confusing to you, so I will explain this a little bit more. So let's look at HCl, which is an acid, considered an acid, a strong acid actually. So HCl, what it does is it deprotonates into H plus Cl minus. And then let's look at a base, NaOH, a strong base. This will deprotonate into Na and OH. So Na plus OH minus. So the reason why I'm saying that acids are proton donors and bases are proton acceptors is because this H plus, when combined with this OH minus, will give you H2O. Basically, this NaOH will accept the hydrogen from the HCl to form water, and that's considered neutralization, because any acidic tendencies and any basic tendencies from HCl and NaOH will be neutralized because the H plus and the OH minus, who have those acidic and basic properties, will combine to form water, which has none of those properties. So that's why we call them proton donors and proton acceptors. Now there are plenty of acids and there are plenty of bases. You could probably list a lot, and you might get some confused. Like, some people consider alcohols, like rubbing alcohol, to be acidic. They're not really acidic, or at least for our purposes, we don't consider them acidic yet. So yeah. So next, we'll be going over the concept of a strong base and a strong acid, and also weak acid and weak bases. But basically, a strong base or a strong acid is something that will deprotonate completely. And by that I mean, let's go back to HCl. A strong acid like HCl, let me just rewrite this. A strong acid like HCl will completely, and I mean completely, deprotonate into H plus and Cl minus. There will be no situation where if you put HCl in solution, you'll not have just a solution of of H plus ions. But there are examples of acids. In fact, most acids are not strong. Most acids do not completely deprotonate into just a little pool of ions. For example, acetic acid. Let me see if I can remember I think it's this. Acetic acid does not completely deprotonate into the base and the H plus ion. So we write it out as this. Basically, this indicates that not all of this acetic acid will decompose or deprotonate into these ions. Therefore, they're not considered strong. They do not completely deprotonate. That means they're not they don't show the most raw, pure acidic character. The same thing goes for bases. So here are all of the strong bases and strong acids. From this list, you know that any other acid or any other base that is not on this list is considered weak. Therefore, it does not completely ionize. So, for example, HCl, that's kind of the most iconic one. And then you have hydrobromic acid, hydroiodic acid, chloric acid, perchloric acid, nitric acid, sulfuric acid. Now, there are patterns in the PR table where you can see, I'll show you this in another video, but this most shows in strong bases where almost all of the group 1A metals are forming strong bases, and almost all of the alkali metals are forming strong bases. So that's kind of a good trend to realize. So last really important thing in this chapter is neutralization reactions, and I kind of went over this just like a couple minutes ago. So a neutralization reaction is just something where you see an equal amount of a base and equal amount of an acid coming together reacting to form water. So I will just simplify it. So all bases and all acids, or all Lewis and Bronsted acid bases, the basic type of, the most simple version of them, involve an H plus ion reacting with a OH minus ion. And if you add them together, you can see that this will form water. And water shows practically no acidic or basic character, besides sometimes when it ionizes itself, which is very rare. Although it does do that a little bit, but we'll get into that later. So based off of this example, we could see that most, if not all, acids in the case of this class will fall under this definition. So, like our previous example, we could use HCl plus NaOH. Now we see that the H and the OH of these two compounds will come together and form H2O, thus neutralizing each other. And then we can also see that a salt is formed, the salt being NaCl, basically just salt. So this goes for literally every single acid or base, strong or not, weak or not. If you have equal amounts, they will neutralize. Although, if you have a weak one, sometimes they don't completely neutralize, or stuff like that. We'll get into that later. But yeah, that's all for the basics of acids and bases.